So this is AMU5L4. We're going to talk about trig functions and special triangles. This will probably be mostly review, but it could help you catch something that you've never understood or get a little bit better at using the trig functions. Now, the trig functions are going to deal with right triangles. So of the three angles, one is a 90-degree angle. Now you have three sides. Of these three sides, one side is your side adjacent, one is your side opposite, and one is your hypotenuse. A lot of times people get confused between the side adjacent. They can't tell which one it is. For example, if this is angle A, and I say, what is the side adjacent for angle A? Well, remember this, the side that's opposite of your right angle is your hypotenuse. So go ahead and pick it out first and label it. Now, since this side is your hypotenuse, it cannot be your side adjacent. You only have one side left that could be your side adjacent. Now, if you change angles, like if I come down here to angle B, and I say, okay, what's my side adjacent for B? Well, then see, the labels change. So these labels depend on which of the two angles you're looking for, the two acute angles, because the 90-degree angle is not going to have a side adjacent. Okay, we're not going to deal with that. All right, so let's look at our functions. I know you've heard these before. You've got sine and cosine and tangent. Now, what are their definitions? Well, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, and there's a lot of different ways people remember this. Some of you do SOHCAHTOA. I always tell mine, some old hippie caught another hippie tripping over apples. Whatever, however you want to remember it. Now for the other three are what we call reciprocal functions, because they are actually just these flipped upside down. It's remembering which one goes where, because you have reciprocal functions and you have co-functions. For example, sine and cosine, those are co-functions, but they're not reciprocal. The reciprocal of sine is your cosecant function. So that is equal to that's equal to your hypotenuse over the opposite side. And then the reciprocal of cosine is the secant function, and that is hypotenuse over adjacent. And cotangent is also, while it is a co-function of tangent, it is also the reciprocal, so that's going to be adjacent over opposite. It just flips them upside down. Now this also means that I could write cosecant as 1 over sine. These are definitions. And secant is equal to 1 over cosine theta, and cotangent is equal to 1 over tangent theta. So just a little bit of an added definition there. So let's grab some triangles and we'll start applying it, and it'll be a lot easier that way. Okay, for number one, we have our triangle here, and here's theta. So we see the hypotenuse is 13, the side opposite is 12, and the side adjacent is 5. So we're just going to fill in our definitions. If sine was opposite over hypotenuse, well, that's 12 over 13. And remember, cosecant is your reciprocal function. So you can just go ahead and put 13 over 12. Then we're just going to flip that. All right, cosine is adjacent over hypotenuse. So that's going to be 5 over 13. And secant is 13 over 5. And you want to leave your fractions improper. Now they need to be lowest terms. But as far as changing them to a mixed number, that's going to defeat. We need to be able to see the sides. And if you change it to a mixed number, you can't tell which side was what. All right. Tangent is opposite over adjacent. So my side opposite is 12. My side adjacent is 5. And then my reciprocal function, cotangent, is 5 over 12. Okay, let's look at number 2. We have a right triangle. Here's theta, and the side opposite is 4, the side adjacent is 8, and the hypotenuse is 4 square root of 5. Now we are going to run into a problem with this one because you have that radical, and remember you cannot have a radical in your denominator. So if we get one there, we'll see what we can do about it. So first of all, sine is opposite over hypotenuse. So I go to theta, my side opposite is 4, and my hypotenuse is 4 square root of 5. And look, right off the bat, when you have that radical in the denominator, you have to rationalize it. So first let's simplify it. 4 over 4 cancels out, so you have 1 over square root of 5. Now how do you rationalize the denominator? Well, you multiply it times itself. And to justify it, you do it over itself because this equals 1, even though it looks different. So when you multiply all the way across, you're going to get square root of 5. Now, what is square root of 5 times square root of 5? Square root of 25, which is 5. So your final answer here for your sine is going to be square root of 5 over 5. Now, let's look at cosine. Our cosine is adjacent over hypotenuse. So I'll go to theta, and my adjacent side is 8, and once again the hypotenuse is 4 square root of 5. So let's simplify first. That's going to give me 2 over square root of 5. I'm going to multiply by square root of 5 over square root of 5. So the top becomes 2 times square root of 5. The bottom, square root of 5 times square root of 5 is square root of 25, which is 5. So I have 2 square root of 5 over 5. Okay, and then my tangent, which is opposite over adjacent. From here, my side opposite is 4, my side adjacent is 8. That just makes 1/2. All right, now let's do our reciprocal functions. Now let's get the tangent first, because 1/2, when you flip it, that's just going to be 2 over 1, which is 2. Now, when you are doing your trig functions, if you had to rationalize a denominator in the sine function, that doesn't mean that you have to rationalize the denominator for the cosecant. And this is what I mean. What is your cosecant? Well, it's going to be hypotenuse over opposite. So let's just come back to our measurements and see what that would get us. The hypotenuse is 4 square root of 5, and the side opposite is 4. So these two, oops, that's a fraction. These two cancel out. So all you have is square root of 5, which is perfectly fine. So you didn't have to rationalize it if you went back to the beginning. Now, if you had taken this and just flipped it, that's going to put the radical in the denominator, and then you would have to rationalize it. You're going to get the same answer. It's just a lot more work. So now let's go to secant. Secant is hypotenuse over adjacent. So when I come here, I've got my hypotenuse, which is 4 square root of 5. My adjacent side is 8. This reduces down to square root of 5 over 2. So key takeaways. If you have a radical in your denominator, you must rationalize it. And if you had to rationalize your sine function, that doesn't mean you're going to have to rationalize your cosecant. You could if you have a radical on both, but you know, it's worth a try to go back to the beginning instead of just flipping it. Okay, for number 3, we have a right triangle, but they only give us 2 sides, so I'm missing a side. Well, we know how to find a missing side of a right triangle. That's going to be your Pythagorean theorem. And you will probably use that more often in trig than you ever did in geometry or algebra. So anyway, to solve, you know it's going to be side squared, which is 20 squared, plus, and I'll just make this side b. B squared is equal to your hypotenuse squared. So we've got 400 plus b squared is equal to 841. Subtract 400 from each side, and b squared is equal to 441. And then take the square root of each side, and that is going to give us 21. Now once again, we're not going to consider the positive negative case here because we're talking about measurement and there is no negative. So Now this side is 21. Now we're ready to fill in. If sine is opposite over hypotenuse, that's going to be 21 over 29. And cosine is going to be the side adjacent over the hypotenuse, so that's 20 over 29. Tangent is your side opposite over your side adjacent, so that's 21 over 20. Nothing reduces down. There's no radicals to worry about, so now let's just flip it. 29 over 21, and 29 over 20, and 20 over 21. And that's all there is to number 3. Okay, let's look at number 4 now. Once again, we are missing a side. This time we're missing the hypotenuse. So when we use the Pythagorean theorem, we're going to do 6 square root of 3 squared plus 6 squared is equal to h for the hypotenuse squared. All right, when you square this, now remember you're going to square the number outside, so that's going to be 36. When you square square root of 3, that's the square root of 9, which is 3. So now you have 36 times 3 plus 36 is equal to h squared. All right, 36 times 3 and then plus 36 is 144. And then we're going to take the square root of each side. So my hypotenuse is equal to 12. Okay? So now we have all that information we need. We can erase that. All right, our sine of theta is opposite over hypotenuse. So from theta, here's my side opposite, 6 square root of 3 over the hypotenuse. It's not irrational, but it can reduce down. So 6 can go into 12 2 times. So my sine is going to be square root of 3 over 2. Okay, then my next one, cosine theta, is cosine is adjacent over hypotenuse. So it's going to be 6 over 12, which is 1/2. I'm not even going to do work on that. Okay, tangent is opposite over adjacent. So what's that going to be? Well, opposite is 6 square root of 3. Your adjacent is 6. Those cancel out. So it just leaves you square root of 3. Okay? All right, now let's go do our co-functions. So this one, since I've got a radical on the top, if I flip it, I'm going to have to rationalize it. So I'm going to come back to my beginning. Cosecant is hypotenuse over opposite. So if I do 12 over 6 square root of 3, I'm still going to have to rationalize, but that's all right. So now I have 2 over square root of 3. I'm just going to multiply both of them by square root of 3 over square root of 3. On the top, I'll have 2 square root of 3. Now on the bottom, square root of 3 times square root of 3 is square root of 9, which is 3. So my final answer here is going to be 2 square root of 3 over 3. Okay, my secant function, I just have 1/2 here, so I am just going to flip that, and it'll be 2 over 1, which is 2. Now for my tangent function, it's probably not going to matter how I do it either way, because this is actually square root of 3 over 1, so if I flip it, it's going to be 1 over square root of 3. This is for my cotangent function. And if I did it this way, if I said the side adjacent, which is 6, over the side opposite, which is 6 square root of 3, yep, I'm going to have to rationalize either way. So I'll do square root of 3 over square root of 3. So that's going to give me square root of 3 on top. 3 times 3 is square root of 9, which is 3. So we have square root of 3 over 3. So it gets a little messy, but you just got to pay attention. Okay, on numbers 5 through 8, they don't give us a picture of a triangle. You can draw one out if you want to, but you really don't need one. So let's get the relationship here. What is the tangent function? Well, your tangent is your opposite over what? Your adjacent. So you only need 3 values. You need an opposite, which is 7. You need an adjacent, which is 24. And you need a hypotenuse, which I don't know. But how can I find the hypotenuse? Well, Pythagorean theorem. If you do 7 squared plus 24 squared equals h squared, 7 squared plus 24 squared is going to give you 625. And then when you take the square root of each side, h is equal to 25. So now you have all the information you need to fill into your functions over here. Sine is opposite over hypotenuse. So if you take 7 over 25. And cosine is adjacent over hypotenuse. So that's going to be 24 over 25. And your tangent is your opposite over your adjacent. So that's going to be 7 over 24. I don't have any radicals and nothing reduces, so let's just go ahead and use reciprocals to get these. So it's going to be 25 over 7, 25 over 24, and 24 over 7. Okay, for number 6, they give us the cosecant of theta. Now, cosecant is hypotenuse over opposite. So I need to find my side adjacent. Well, let me go ahead and write that out here. So now our side opposite is 12. Our hypotenuse is 37. And we want to find the side adjacent. So, Pythagorean theorem. We're going to put 12 squared plus the side adjacent, we'll call it a squared, is equal to h squared, which is 37 squared. So you got 144 plus a squared is equal to, and 37 squared is 1369. Subtract 144 from each side, and that's going to give you 1225. Take the square root of each side, and a is equal to 35. Okay, so our side adjacent is 35. And there you have everything that you need to fill in your 6 functions. Sine is opposite over hypotenuse, and it won't reduce. Cosine is adjacent over hypotenuse, 35 over 37, and tangent is opposite over adjacent. So that's going to be 12 over 35. All right, let's flip them all. So this will be 37 over 12, and this will be 37 over 35, and this will be 35 over 12. Okay, for number 7, they tell me that the cosine of theta is equal to 5 over 9. So what sides are cosine? This is your adjacent over your hypotenuse. So if I'm labeling everything, my side adjacent is 5. My hypotenuse is 9. And my side opposite, I don't know. So I'm going to have to use Pythagorean theorem. Now remember, it's going to be 5 squared plus, we'll call it O squared, equals h squared. All right, 25, oh, and I know what h is. 25 plus O squared is equal to 81. So subtract 25 from each side, and that's going to give you 56. And then we're going to take the square root of each side. All right. Now I need to simplify 56. So what is a perfect square that will go into 56? 4 will. So I can rewrite this as 4 times, square root of 4 times 14. So that's going to be 2 onto the square root of 14. So this is our side opposite, 2 square root of 14. Okay, so let's start filling in. We're probably going to have to rationalize some denominators since I have that. Okay, for sine, that's opposite over hypotenuse. So that's going to be 2 square root of 14 over 9. My cosine is going to be adjacent over hypotenuse. So that's 5 over 9. And my tangent is opposite 2 square root of 14 over my adjacent, which is 5. Now for cosecant, you flip this. So 9 over 2 square root of 14, you have to rationalize your denominator. Now you're just going to multiply by the square root of 14. Okay, so that's going to be 9 square root of 14 up here. 14 square root of 14 times square root of 14 just makes 14, and 2 times 14 is 28. All right, now on your secant, you can just flip this one. So that's going to be 9/5 here. We circle them over here. And then for your cotangent, once again, you're going to have to rationalize that denominator. So it'd be 5 over 2 square root of 14. You're going to multiply by square root of 14 over square root of 14. So we have 5 square root of 14 over, that makes 14, 28. Okay. And there are your 6 trig functions for number 7. Okay, number 8 says secant of theta is equal to 4, and I need to get 3 sides out of this. Now on the other ones I had a fraction, so I could get 2 sides. Well, just remember, any whole number is itself over 1. So the definition of secant was h over a, so my hypotenuse is 4, my side adjacent is 1, and my opposite I don't know yet. So let's use the Pythagorean theorem. I'm going to do o squared plus 1 squared is equal to 4 squared. So o squared plus 1 is equal to 16. Subtract 1 from each side, and o squared is equal to 15. And then take the square root of each. So the side opposite is the square root of 15. Now we are just ready to plug these in and rationalize if necessary. So first of all, sine of theta is opposite over hypotenuse, so that's square root of 15 over 4, which is fine. All right, cosine of theta, which is adjacent over hypotenuse, is 1 over 4, which is fine. And tangent is opposite over adjacent, so that's square root of 15 over 1, which is just square root of 15. Okay, those worked out fine. Now let's do cosecant. Cosecant is hypotenuse over opposite, so that's going to be 4 over square root of 15, and we need to rationalize. Square root of 15, square root of 15. So this is going to give us 4 times square root of 15 on the top. Square root of 15 times square root of 15 is just 15, and those won't reduce. All right, our secant is just this flipped. So we can just put 4 there. And then our cotangent is going to be this flipped, so it would be 1 over square root of 15. And we're going to multiply both sides, top and bottom, by square root of 15. So that's going to give us square root of 15 over square root of 15 times square root of 15. The radicals cancel out, so you just have 15. Okay. So there you go. So the last thing we're going to talk about is 2 special triangles, the 30, 60, 90 and the 45, 45, 90. And these are special just because they occur so much. Now, their relationships are worth studying, and that's what trig is. It's the study of relationships between one of the angles and 2 of the sides. Now, for example, if you have a 30-degree angle in a triangle, and let's do it this way. Remember, these are all right angles. And it can be, it doesn't matter how big it gets. All right? If the sine of 30 degrees, which is side opposite over hypotenuse, is 1/2, then that means this is 1 to 2. It's 1 to 2 here. Now that's proportion. And that's where these numbers come from. The little side is x, or 1, the single, whereas the hypotenuse is twice that. So it doesn't matter how big your 30-degree triangle gets. If this hypotenuse is 50, it means this is 25. If this small side over here is 8, it means this is 16. The relationship between those 2 sides never changes as far as proportion goes. The hypotenuse is always going to be twice as much as the short side. So when we memorize or get very familiar with these relationships that are right here, and you might want to write this on your diagram. Your short side is always x, your hypotenuse is 2x, and your other side, which is the side adjacent, remember we're talking about the 30 for right now, is x over square root of 3. Whereas with your 45, 45, 90, well, naturally your two legs are the same because it's an isosceles triangle. Your hypotenuse is square root of 2. So another way you could use this, let's say in a 45, 45, 90 degree triangle, somebody said, well, my hypotenuse is 7. What's the length of my leg? Well, what you can do there is use this descriptor and make an equation over it. X is equal to square root of 2. And then you would divide both sides by square root of 2. So your leg is equal to 7 square root of 2, which you would have to rationalize, yes. And I'm not going to go through all the math because I'm just trying to make a point. But anyway, you need to be very, very familiar with these expressions. Some teachers will make you memorize them. I'm not going to make you memorize them because you have your notes for the test, but just know that they exist, and then we're going to look at how to use them to find the trig functions of these two special triangles. Okay, so let's look at our chart and let's fill it in by looking at our two triangles. First, let's do our 30-degree angle. Now, the sine of 30 degrees is going to be the opposite over the hypotenuse. So you have x over 2x. Your x is reduced down, so that's 1/2. So what that, and this is based on a unit 1 for x. So if x was 10, like I said, this would be 20. It's still going to reduce down to the half. That is the relationship. All right, for cosine, that's going to give you x square root of 3 over 2x. These x's cancel out, so you have square root of 3 over 2. The tangent of the 30-degree angle is going to be x over x square root of 3. Your x's cancel, and you're going to have 1 over square root of 3. Then you're going to have to rationalize, multiply by square root of 3 over square root of 3. And that's going to give you square root of 3 over 3 for your final. All right, cosecant, we're just flipping the sign, so that's going to be 2. For secant, we would flip this and then rationalize. So that's going to give us 2 square root of 3 over 3 over 3. And then our cotangent will just reduce down to square root of 3. Okay? Now let's come down here and do the 60-degree one so we can finish up this triangle, and then we'll do the 45 one. Okay, now we're changing. We just did all the functions based on the 30-degree. Now we're going to focus on the 60. So all that does is it changes which side is the adjacent and which one is the opposite. All right, so when you find the sine of the 60, that's going to give you square root of 3 over 2. No reducing necessary. Your cosine of the 60 reduces down to 1/2. Your tangent of the 60 will give you square root of 3. The cosecant of your theta will give you 2 square root of 3 over 3. And all I've done is take the opposite over the hypotenuse, the opposite over the adjacent, and just simplified them from these expressions here. All right, your secant is just going to be this flipped, so that is 2. And your cotangent is going to be this flipped, but then it has to be rationalized, so that would be square root of 3 over 3. Okay? Now the 45, 45, 90 one is easier because 2 of the sides are just 1x. So the sine of, and you only have to do one angle because they're both going to be the same. So the sine of your 45-degree angle is side opposite over hypotenuse, and this is what I'm doing. If you do side opposite over hypotenuse, which is x square root of 2, and then the x's cancel out, well, you still have to rationalize that. So square root of 2 over square root of 2 is going to give you square root of 2 over 2. So that's how I'm doing every single one of these. Some have to be rationalized and some don't. Okay, your cosine, which is adjacent over hypotenuse, well, that's going to be x over x square root of 2 as well. These cancel, 1 over square root of 2, square root of 2, square root of 2. So once again, you get square root of 2 over 2. All right, your tangent, which is opposite over adjacent, that's x over x, which is just 1. And what does that mean? Your cotangent is just going to be 1 as well. Then your cosecant and your secant, when you figure them out and reduce them all down, it's just going to be square root of 2 for both of those. So your 30, 60, 90s, it's not a mystery, it's just that they're so common, they've come up with these expressions so that you don't have to figure them out from start to finish every single time, okay? So let's dig in here and let's work some problems, because it's easy to watch me do them, but can you do them without me? So go to the practice page and see how you do.